Good afternoon, everyone. Welcome and thank you for joining us today. I am Mohammad Murtaza. I'll be the host for this session. It's great to see professionals from across the MEP industry representing consultants, contractors, designers, project engineers, all coming together in one place. In our industry, we don't have a knowledge problem, we have a knowledge sharing problem. Every project teaches something valuable, but most of the learning stays within the individuals or organizations. That's exactly why we aim to change through the UAE MEP engineers community, a platform where we actively share codes, based insights, real project case studies, MEP challenges and their discussions, career development content, and future focused topics in construction industry. The goal is simple: learn together, grow together, and raise the standard of MEP engineering within our region. The webinar series and the community initiatives are currently being sponsored by MCube Engineering Consultants, sponsoring the community and also providing and empowering all the engineers within the Middle East. MCube Engineering Consultants is a multidisciplinary engineering consultancy providing services like MEPF design or authority approvals, engineering supervisions, electrical design systems, fire protection systems, energy audit, and sustainability consultant. Today's webinar will be focusing on arc mitigation and thermal monitoring solutions in LV switchboards, which are critical for electrical safety, equipment protection, reducing downtime, increasing reliability, and supporting predictive maintenance. It is my pleasure now to introduce our speaker for today, Mr. Srinivas, Consultant Technical Support Manager at Eton, with more than 15 years of experience in electrical systems. Before we begin and I hand over the mic to Mr. Srinivas, a few housekeeping points. I request all of you to kindly mute your microphones during the presentation. If you have any questions, please write them in the chat box and we will be having a Q&A session at the end of the presentation. And all the attendees who have registered will be getting an e-certificate to your email upon completion of the webinar. Now, without taking much time, I would like to invite Mr. Srinivasan to begin the presentation, and the stage is yours. Thank you.
Yeah, thank you for the introduction actually, and thanks for the MQ for arranging this session. So as you said correctly, actually there should be a knowledge sharing. Even in my last 35 years, my experience only in the electrical switchgear field, I have been doing the same. Even today also, I feel that okay, I'm learning something actually. It's only not only I'm presenting, also by presenting, I also get some inputs, good inputs from the audience as well actually. So that is my day-to-day practice. So let us start with this one. So basically, I am working as a technical support manager with the Eaton. I'm handling the technical support for the consultants, especially for the low voltage switchgear, medium voltage switchgear, busway, and the active harmonic filter. I'm with Eaton for the last 6 years. I'm handling the technical support for the whole UAE. So this is my day-to-day support to the consultants actually. Basically, what I'm doing is like LV and MV switchboard panel sizing, busway voltage drop calculation, also the specification update for all these items. Then also I do conduct the training on the software training for the short circuit study, voltage drop calculation, and selectivity. For this, we have the software called Expander software. It's a free software. You can also download from the website, and also support on the harmonic study, any technical submittal review, or any product related queries related to local utility requirements and the product training, as well as any IEC related clarification also. So this is my day-to-day support to the consultants. So in my team, I have 3 more engineers also. So totally 4 engineers are handling technical support for this LB and MB switchboard system and busway. So this is our today's agenda. So we will start with this Eaton introduction, slight introduction about the Eaton and what we does in the Middle East. Also the arc mitigation system. This is a patented design. Also we have the thermal monitoring solution. So we have the 2 solutions. One is a wireless diagnosis system and a wired exam system. Also we do have the arc reduction maintenance system. Again, arc fault detection device. Also there's some special devices like a digital RCCB and some good features in the breaker about the breaker healthiness as well. Then we can keep the question and answer session. So as Faisal has indicated, so you can post your questions in the chat box so that we can discuss at the end of the session. So who is Eaton actually? So Eaton basically we have it's an international company. We have globally having more than 85,000 employees, and we are spread across the 175 countries in the world. And our last year we did the turnover of 27.4 billion US dollar, which is almost a 10% higher compared to the previous year, 2024. Eaton, we started the career, our profile with the truck axle manufacturing company, and we grown in the industrial diversified industrial segment. Then we reached more into the electrification field. Now it's we can say that it's intelligent power management company, one of the leading intelligent power management company globally. As a Eaton, we committed to spend almost close to $3 billion by 2030 for the R&D activities. So far, we have invested 1.3 billion US dollars for the R&D activities. We have the 6 innovation centers across the globally, more than 10,000 engineers working on that one. So far, as average, we can say like a 312 first patented design we have been making. So it's clearly giving a indication that Eaton is one of the good innovator globally, and we have been named as one of the top 100 global innovators. This is the release. It is released by the Derwent company. So this clearly, the slide which I'm showing, it clearly indicates that we started our way from since 1911. As and when the years goes, we do also acquire the right companies to increase our portfolio and to meet the market requirements as well, actually. So we have, you might have heard about the global leading brands like a Cutler Hammer for the power distribution, Klockner Muller mainly for the motor control centers. Then we have the Cooper Industries for the life safety devices. So this all now, because we had various brands actually, all those brands now comes under the one umbrella called Eaton. Also in 2019, we acquired a company called Ulusoy, which is based on the Turkey. It's mainly for the medium voltage switchgear and the transformers. Also, we can say our recent acquisition like a Green Motion for the EV charging station and 888 for the UPS as well. So this journey continues actually, acquisition of the right companies at the right time. You could see there are, as I explained earlier, there are 6 different locations. We have the 9 research labs and innovation center across the worldwide. We have in the Minneapolis in the USA, and also we do USA itself. We have the 3 different locations. Also, we have in the Czech Republic in the Europe. Also, we do have in the India, Pune, almost close to 2,000 engineers are working, R&D engineers. Also, we do have the innovation research labs in the Shanghai, China as well. So ethical, that is one of the our part and parcel of Eaton culture. So right from the higher management till the down the line, the blue collar level. So ethical is one of the important point, and we are proud to say that. And Etisphere, this is a third-party company which they recognized us 14th year in a row that one of the Eaton is the best ethical following companies. The products which I said, like whether you talk about the LV or MV switchgear, UPS or a central battery system, any other system which Eaton is portfolio we are having. So this is not restricted to any specific segment of like a residential or anything. So it can be used in various segments. So right from the critical aerospace till the building level and residential construction or data centers, oil and gas, healthcare, all this segment we can use our products. So we also, again, we are proud to announce that, okay, Eaton has signed a joint venture with JobSA for, for manufacturing facility in the Jabalali. So that is under construction now. We are hoping that by Q3 this year, we will be having the factory. And in the joint venture, as per the agreement, we are, it's creating the manpower for the 700 high skilled job actually, also which is giving opportunity for the young Emiratis as well. So what we do manufacture in that facility? So we'll be manufacturing the printer circuit board, electronic boards, and also we'll be making the MCBs close to 20 million poles. Also, we do have the engineering center over there, and also new facility. Maybe if the things goes well, then we'll be implementing manufacturing of the other products as well. Okay, now coming to Eaton portfolio, we have the MV and medium voltage switchgear and transformers up to 33 kV. We do have the oil type and the drive type transformer, ring main unit, and the medium voltage switchgear. And then coming to the low voltage system, we do have the cubicle system up to 7,100 amps type tester design. And we are proud to say that we are one of the company registered with even the ADDC Abu Dhabi. Now it's they called TACA. And we have the registration up to 7,100 apps. Only 2 companies having such higher rating with approved with ADQCC in Abu Dhabi. And coming to the power distribution components, we do manufacture the ACB, MCCB, and the MCB, busway, capacitors, and G2 reactor. In the industrial control, we do manufacture the motor starter components like fuses, fuse switches, and contactor, overload relay, intelligent motor protection relay. Then when coming to the digital power quality and the critical power systems, we do have the UPS system. Also, we do have the software system as well. And coming to the life safety, we manufacture the central battery, emergency lighting, and the fire alarm system. So whatever you are seeing on the screen now, all these products which is coming from the Eaton directly. So now we will jump into the core topic of the arc fault protection system. Eaton having the patented design of Arcon for the arc mitigation device. So before jumping to the Arcon, the arc finishing device, we'll talk about what is meant by the arc flash actually. Okay. Basically, if you look into the, you might have seen in the single line diagram that in our single line diagram, we indicate electrical terms that like ICW, 50 kA for 1 second or 50 kA for 3 seconds. So what we do, we fix the bolted shorting at one location. That means the short circuit point is fixed so that it is immovable in general. Okay. But this is nothing but the low impedance short circuit. On the other side, suppose when in the live switchgear, by mistake, and suppose if there is a torque wrench or spanner or wire which falls between the faces, which create the arc actually, which is nothing but the high impedance arc, and which is uncontrollable actually. When such a high impedance arc is happening, what's happening is then it reaches a very high, enormous temperature actually, melting of the parts. Also, the parts which can eject from the bus bar or bus bar supports, it will eject, and also it will produce a very intense light and a very hot hair expansion also, which all happening very quickly actually before our blinking of the eyes. So this is a very important one. Normally when the internal arc is happening, if you see the graph, within 10 milliseconds as well. So now the point here is we need a arc mitigation device. We need a arc mitigation device that should mitigate the arc in less than 5 milliseconds, so that we can avoid the extent of the damage, or we can say that we can limit the damage actually. Okay. Now in the globally, as of now, if you see into the market, most of the time what you could see when there's arc mitigation device means most of the manufacturer having the arc protection relay. From the output of the arc protection relay, they are giving the signal to the breaker to clear the fault. For example, if you give the arc protection relay output to the ACB, the ACB to respond, which it takes 50 milliseconds. Whereas if you look into the graph, within 10 milliseconds, which is reaching the highest temperature actually. But our intention is we need to limit the the arc flow in the network actually. So we need the device which should be less than 5 milliseconds. That is very important. So these are all the impact happening on the internal lock switchgear, like extreme heat, the metal switchgear mold melting, very high pressurized waves, sound waves also, the sharp materials which is rejecting out, very hot hair expansion, and intense light. So these are all the unpleasant activities which is happening when the internal lock is happening inside the switchboard. I will show a small video. Supposing the event of if the switchboard is not type tested for the internal lock, what are all the consequences happening? This is available. I took it from the YouTube. This is the real arc flash incident. You could see the impact of the internal lock. It's questioning the threatening life to the human being, the operating personnel, also for the switchboard as well actually. So the internal lock is one of the very critical requirement for the switchboard system. So how we can improve the safety of the switchgear? So basically, the any switchgear, we are expecting that it should have been type tested basically for the IEC 61439-2, which is ensuring proper internal partition. Also, we can improve by having the completely withdrawable cubicle system. If the switchboard has been seismic tested, that means earthquake. Also, we can have the preventive measures. We can go for the temperature monitoring. That also will be is covered in my presentation in the forthcoming slides. And also we can use the arc reduction maintenance system in the breaker level. Also we can have the zone selective interlocking for the better discrimination. Also, if you have the switchgear which has been type tested for the internal lock as per IEC 61641, that also improve the safety. Also, we can talk about the arc mitigation once at the highest level actually. By mitigating the arc, still we can enhance the protection to the entire system, also for the human being operating personnel. So just we will talk about the little bit about the basically how the internal arc being tested and what are the criteria as per IEC 61641. So first you need to remember that this is nothing but this only passive system. It's not active system actually. So these are the 7 criteria. The criteria number 1 says that during the internal lock, what they will do, they will take a small piece of wire like a 1 mm dia wire. They will connect, they will make a shorting between the two live phases. So during that, and when they inject the power, okay, the external doors or covers should not get open, okay, and none of the parts should fly off from the switchgear to the towards outside direction. And they will be keeping a one small cloth around the switchboard at 1 feet distance. What you are seeing, this black color square, which is nothing but a cotton cloth, that should not catch fire in the event of internal lock. Also, it should not create any holes in the switchgear. I mean, the external parts of the door or cover, it should not create any holes. If any holes is getting created, what will happen is the hot air will come out, or even the flame will come out. It will affect the human being. Also, the ground earth continuity should be ensured. Also, suppose assume that if the internal arc is happening in the cable compartment of the switchgear, okay, on one particular feeder, outgoing feeder, only that the arc should be confined within that cable compartment only. It should not spread the arc to the nearby busbar compartment or breaker compartment. That is not accepted actually. Also, rest of the cubicle should be active so that we can put back the switchboard into the service. So the meaning is, except the affected compartment, rest all the switchboard should be alive so that we should be able to continue the operation. As far as the E10 is concerned, we have type tested our various form for switchboard systems like X Energy and X Powering, which has been tested for all the 7 criteria. And we have achieved the highest arcing class of arc class C. So now, if you look into this slide, you could see more red color arrow marked one, and also you could see the green color arrow marked one. Now our patented design Archon, so which will be suitable for if there is an internal arc is happening in all these red color arrow marked points. The points what's happening is, I will make it explain detail on one more time. For example, this is one of the outgoing feeder cable compartment. If the internal arc is happening in the cable compartment, we don't need to shut down the main incomer, okay, because it's only this specific outgoing feeder cable compartment has got affected. So the FM team person, they can easily, maybe they can unterminate the cable, and again they can do the cleaning operation. Again they can terminate the cable in the proper way, and they can put back into the service. So this is very easy. Somehow the FM team can manage. But if there is an internal arc is happening on this incoming side of the outgoing breaker or main bus bar or dropper bus bar or in the incomer ACB cubicle, it will be difficult to, to carry out the maintenance or replacement by the FM team. Suppose assume that if there is an internal arc is happening in the main bus bar chamber, if the main bus bar chamber, we are sure that definitely the FM team, they may not be having the bus bars and the supports as a spare items, okay. So if any big such internal arc is happening in the main bus bar or dropper bus bar, so definitely they need to call uh, the particular panel builder or OEM manufacturer. So they need to come to the site and they need to replace all the bus bars and supports the site. Sometimes, depending upon the severity, it may take a few days. Sometimes it will take even a week or 10 days time also to replace the complete bus bar system. Suppose assume that if you are having a switchboard of like oil and gas or even the data centers or industries or any critical application, so there are possibilities that the switchboard width will be huge actually. Maybe sometime you will be having a switchboards with ranging from 7 meters to even 10 meters also. So in those cases, replacing the bus bar and support at the site, which is not easy thing. So this is where Archon comes into picture. So first I will explain how this Archon works actually. Okay. Suppose if in the event of internal arc is happening, That means if any screwdriver or torque wrench or small piece of wire or even small lizard which falls between the two faces, which creates an internal arc. The internal arc is nothing but, as I said earlier, it is a high impedance short circuit. In general, majority of the cases, the internal arc value will be between 5 to 15K in majority of the cases actually. Suppose assume that even if you're having ACB having the instantaneous short circuit protection, the time required by the instantaneous short circuit protection to clear the fault, it will take more time actually. It will take more time actually. So now what's happening is, once if the internal arc is happening, this arc-on or quenching device, which will be activated, I will explain the next slide. So that will create the parallel low impedance short circuit. Okay. Earlier, the short circuit energy was flowing through this internal or through this path. Now this is parallel to that one, we are having a low impedance path. So that means it is a tendency that normally the current try to flow towards a low impedance path actually. So the energy which was flowing through the arc path, which is cut off actually. So that the arc is getting quenched. Now the internal arc, the current is flowing through the short circuit, low impedance short circuit, which was enabled by the arc-on actually. So by creating the low impedance short circuit, now the prospective fault level in the system, it will get increased actually. For example, if I go to the, as I said, the internal arc will be normally generally between 5 to 15K majority of the cases. Now after the Arcon made the low impedance short circuit, it will reach the prospective fault level. For example, if I take a 1500 kVA transformer, the prospective fault level will be like a 36 kVA. Now, you can ask the question that already the fault current was low, 15 kVA, example. Now it is reaching the prospective fault level of 36 kVA. But the point to be noted is, the moment if the made the low impedance short circuit, the energy which was flowing here to assist the arc to sustain, that is getting killed actually. Our main thing is the arc should get killed at the earliest actually. It's all happening in less than 2 milliseconds, the arc is getting quenched. So once if the low impedance short circuit is created, and after reaching the prospective fault level, then the ACB or any other breaker, it will be signaled to get tripped. So totally the power feeding to the switchboard will be isolated. But the point to be noted is, by having the arc-on, you can put back the switchboard into the service by doing simple cleaning operation. No need of any major replacement. Also, every time once if this arc-on has got actuated, it needs to be replaced. It is acting like our airbag in the car. As long as a car it does not make any big impact, the airbag will be intact. Suppose if there is a car is hitting with a hitting the another car or any poles or something, hitting very fast, then airbag will get actuated. Then you need to replace airbag. Similar way, once if the arc-on it has got activated, then we need to replace it with a new one actually. Now, replacing the arc-on and simple cleaning inside the particular affected compartment, all these things you can make it in less than 45 minutes actually. Whereas in the other scenario, if you don't have the arc-on in the switchboard, if the internal arc is happening, example as I said in the main bus bar system, it may take a number of days or even a week or 10 days also it will take actually. So that can be totally avoided. In this case, by using the arc-on, you put back the switchboard into the service in less than 45 minutes. So that is the only thing any facility management team they need to think of. So how this is working principle is, so normally we are getting the input from the two input. One is the optical, the light sensor. Another one is from the current sensor. Both this input, which is feeding to the main relay. So that is evaluating that one. So that is evaluating that one. Then it is feeding the signal to the arc-on to get activate. Then arc-on making the shorting actually. All these activities, that means getting the input from the two optical light sensors and the current sensor, the signal being evaluated by the master relays and giving signal to the arc quenching device, and arc-on is making the shorting, which all happening in less than 2 milliseconds actually. So that means before the blinking of the eyes, the action is getting completed actually. That means the arc is getting quenched in less than 2 milliseconds. That is the only thing we need to highlight it actually. So this is giving a simple single line diagram representation of the sequence of operations actually. So the arc is getting initiated. It is giving the light signal, and also the CT which is giving the current sensor, then which is giving to the ISCD device. Then we are giving the signal to the arc quenching device. Then in turn, also we are giving the signal to the short circuit protection device. So at the end of the less than 2 milliseconds time, at the end of the 2 milliseconds time, the complete arc is getting quenched. If you look into the both the pictures, you could see there is one insulator plate is there actually. Okay, so before archon is actuating, we make the bolting shot already. Okay, before archon is actuating, there is insulation plate, so both the short circuit will not happen actually. Once if the archon is actuated, this insulation plate will get a break, then it is making the continuity of the short circuit. Already bolting operation has been done already. So by penetrating this plate, insulated plate, now we could see that there is a connection, proper short circuit, three-phase short circuit is happening. I will show the small video. Once if you have without archon and with archon, what is the impact happening in the switchboard actually. You could see the kind of the fumes gas which is coming out of the switchgear. If the internal lock is if the archon is not installed the switchboard, you might have noticed that we put one dummy like a human being. So you could see the distance of approximately, we can say, like a 7 to 8 meter distance. So the fumes and gases which is emanating from the switchgear, which is reaching the human being, even if he is at the farthest distance of like even like 7 meters, 8 meter distance actually. In the same switch here, after installing the archon, you could see the impact. You could see some small carbonized gas which is emitting from the board, which is very, very negligible compared to the case where if the switchboard is not having the archon. Okay. Even when we did the switch, maybe you can notice over here, the door was closed, completely closed here actually. But if you see in this case, even we kept the breaker door, compartment door also we kept open. So that means the level of protection, safety to the human being, when the archon is installed inside the switchboard, it's very, very highest level actually. Normally when the any manufacturers or panel builder, when they go for the type testing of, especially for the internal lock, they pay very high attention to ensure that the doors are secured, closed and locked properly actually. But by having this archon or quenching device, we are with confidence, they are keeping the door open actually. That means safety to the human being, also safety to the switchboard also. So that is a level of safety being offered by the archon. There are some international standards because mostly you might have noticed that the internet IEC 61439-2, very basic standard. We insist for any project specification we could see, it should have been type tested as per IEC 61439-2 for the MDB, SMDB, MCC, like that. And one step ahead, we could see in the most of the project specifications, IEC 61641 requirement. This is mainly for the internal law compliance. Also, now there are some 3 new standards has been launched actually in the last 5-6 years. That's the main thing. Is first one is the 6310. Okay, before jumping into that, I'll go over here. 609479-1. The arc quenching device archon. It has been tested as per this product standard successfully. Also, the light sensor which we are using for the arc mitigation system, that also as per type tested as per this standard. Then both archon and the lighting sensor inside the switchboard, it has been tested for IEC 63107 also. It has been tested actually. So the point, what we are trying to say, the complete switchgear, bus bar, arc quenching device, archon, light sensor, all together, it has been successfully tested as per IEC 63107. We are proud to say that Eaton is one of the leading manufacturer globally. We got the type test certificate for IEC 63107 for our Eaton switchboard system actually. Even you can verify with other manufacturers also. So far, up to our market intelligence, they don't have this one actually. And this is very, very important to increase the safety level of the switchboard, especially in the event of internal lock condition. So just we will give the gist of about the Archon org mitigation device. This device Archon is it's not something a new device. It has been globally, it has been working for more than 35 years. It mitigates the arc in less than 1.5 to 2 millisecond. This Archon can be installed in the third-party application also, according to IEC 61641. And it's working on the design of pyrotechnic actuator, exactly like the same principle of how the airbag operates in the car actually. And this is actually safety above the standard. What I mean to say, apart from whatever IEC 61641 indicates, in addition to that, it is also giving the more protection, also what you call the need only less maintenance time, so that we can put back the switchboard into service in less than 45 minutes. So this Archon arc quenching device has been working, various installed base globally. Even the flight manufacturing facility in Airbus also it is there. BMW car manufacturing company, DuPont, insulation manufacturing. There are so many industrial companies working globally. So now we will jump from Archon arc quenching device into the thermal monitoring system. So normally what will happen is, so whenever after energization of the switchboard once in a year or once in 2 years, the FM team, what they used to do, they have the thermal camera and they will measure the temperature of the joints actually. There are some pros and cons. Mainly we could see there are a lot of drawbacks actually. For example, if you look into this picture, this FM team person who is trying to take the temperature on the particular face of the bus bar. So you know very well, exactly behind this door, maybe you will see only one particular face only, maybe red or yellow or blue only. You cannot measure the temperature of all the three faces within this small window. It is difficult to do that one. Again, if you want to do the temperature measurement for all the three faces, what they need to do? They need to remove the door, or they need to remove this cover actually. Okay. The moment if you're removing the cover or door, the you could say, definitely we may be knowing most of the substation in this part of the world is having air conditioning. So the moment if you are opening the door or cover, then the cool air will go inside. So whatever the temperature you are measuring, it is not the realistic values actually. Also, there is a safety concern. The moment if you are opening the door or protective shrouds inside, then there is a safety concern also. So also it requires some skills for taking the exact measurement at which angle we are focusing towards the hotspot. So this all there are some drawbacks within this conventional thermographic study. So to overcome this one, so we have the system called a diagnosis system. It's a basically wireless sensor system. It can be installed anywhere in the bus bar. It can be clipped onto that one, and also it's working on the principle of called self energy harvesting system. There are some other manufacturers also having the equivalent similar system, but the point is they need auxiliary power supply for operation of the sensor. All also they need the what you call the batteries also needed. You need to replace the battery after some time. Then if you want to replace the battery, then you have to do the shutdown on the safety aspect actually. Okay, so all these things eradicated by having this wireless thermal sensor system. So this wireless thermal sensor system, as I said, we can clip over anywhere in the bus bar. You could see the black color over here. It can measure the temperature up to 150 degrees Celsius. As I said earlier, it's a battery free, and so it's a maintenance free. And we can also having a 24/7. We can transmit the data of the temperature to the higher level like a BMS or SCADA system. We can do that one. Just one point I would like to highlight that only the first point of signal which is going into the measurement is the wireless one. Then from this USB receiving port, which all by wired only, just for the better clarity to you. Also, as I said earlier, we can also see in the BMS or SCADA level, we can see the real-time continuous values of the temperature. We can also see the average values. We can also see the minimum values also. We have the solution for low voltage and also for the medium voltage we have the solution. As I said earlier, by having this diagnosis system, we can have the clear idea about what is the level of temperature, thermal condition inside the switchboard. We can have that one actually, so that we can take some preventive actions well in advance to avoid any thermal issues happening in the bigger way. So normally what will happen is, suppose assume that if the temperature, if the bolted joint, if it was not the proper torque was not ensured, means the temperature will shoot up. Once if the temperature is shoot up, it will increase. Then it will lead to the insulation failure. Then insulation failure will lead to the short circuit. So to avoid all these consequences, if you get the information well in advance by using this thermal sensors, we can avoid any potential damage to the switchboard, and also we can enhance the safety to the perform team as well. So what we have seen earlier, that is a wireless thermal sensors. So now what we are going to see, it's a Exerthem wired sensor actually. Exerthem actually, it was their specialized company for the thermal monitoring system. They are in the market for more than 10 years. About a couple of years ago, Eaton acquired the Exerthem. So just I want to see how the measurement of the temperature, how the evolving the technology. So initially, to see the temperature on the switchgear, the people used to keep their hand on the, like a non-current carrying metallic parts, like in external doors or covers. Then the people use the infrared camera. Then it evolved into infrared windows actually. So now we are reaching the level of thermal sensor, IR, same IR the technology, infrared sensors, monitoring the temperature 24/7. So by having this Exerthem point sensor, we can monitor the temperature in the LV, MV switchgear, transformers, MCC, bus duct, UPS, and the PDU as well. So this infrared sensor, it's a globally accepted measurement concept. It has been, as I said, we have the installed base for more than 10 years. Throughout the lifetime, it does not require any auxiliary. It does not need a auxiliary power, and also it does not require any calibration as well. And we are not having the direct contact with that sensors, zero maintenance, and it's giving the lifetime warranty as well. So this is in case of a cable, you could see here this yellow color cable with the sensor installed at the top. We can just tie with the power cables. For example, assume that if they're taking the MDB incomer, we are having like a 630 square mm cable. So this is small cable wire with the sensor. We can just clip onto that one. If it is placed close to the what you call the termination points, we can have the accurate values actually. So it can be installed in the blue new jobs, old job. That means greenfield jobs. Also, it can be done in the existing brownfield jobs switchboards also. Also, you could see the example of where we are installing the thermal sensor, point sensor in the transformers, both on the high voltage side, also the low voltage side part as well. Also, we can have the sensors in the busway system as well. Whenever we are having the busbar joints and the external enclosure, like normally you could see either it will be aluminum housing or it will be the sheet steel housing. So the place where we are having the joining of the enclosures housing, so there we can place this thermal sensor so that it can give the temperature values 24/7 to the higher level BMS or SCADA system through communications. So it's our wish list. So as I said earlier, the good points are, it's a measuring the temperature 25/7. It does not require any auxiliary power actually, and it is enhance the safety to the switchgear. And as a preventive measure, we can use this system, wired thermal sensor anywhere like a switchgear, LVMV switchgear, busway, even PDU, UPS as well actually. Also, we have the arms protection or reduction maintenance system. What we have seen earlier, Archon is for the entire switchboard system for arc mitigation for the switchboard level actually. And in coming to the breaker level, we are also having option feature called arms protection. So what's happening is, suppose assume that if you are having a one switchboard, one particular outgoing feeder feeding to the one load. For example, if you take it's feeding to the chiller actually. Okay. Suppose in the chiller from the breaker to the chiller, the cable, if you are suppose assume that if you are doing some maintenance work under the live condition, okay, we don't recommend to do any maintenance on the live switchgear, but due to some exceptional cases where some critical applications are there, when we are doing the any maintenance on the live switchboard system, before carry out that maintenance under the live condition, if we enable that arms protection, okay, suppose if there is an internal arc is happening by mistake and due to dropping of the torque wrench or spanner or small piece of wire, if the internal arc is happening, this arms protection built in the breaker, or it can be ACB or MCCB, it is clearing the fault much faster than our instantaneous protection in the electronic tip unit. You might be knowing that if you take any what you call the thermal magnetic breaker or electronic breaker, we have I function, instantaneous short circuit protection. Okay. Example, assume that if the instantaneous short circuit protection is taking 20 milliseconds to clear the fault, whereas if you take this arms protection, which is taking a time lesser than your instantaneous protection activation of time, by having this arms protection, the instant energy level is getting reduced actually. The PPE level, which can be reduced one or two categories down actually. Suppose assume that without this arms protection, the PPE level requirement, for example, PPE3, okay? By having this arms protection in the breaker level, it can be come down to 2 PPE2 or PPE1 also possible actually. So if you look into this table, so normally if I take the arms protection, if you, I am supposed to add here the archon also. If I add archon means within 2 milliseconds it mitigate the arc. If it's arms protection, we can say after roughly like 35 milliseconds it's clear the fault. If I go with the instantaneous protection ACB, it takes 50 milliseconds, and the selective protection takes 100 milliseconds, and the long delayed ACBs it can be even 500 milliseconds. So the point what we are trying to say, by having this arms protection in the breaker, you can we can mitigate the arc in less than 35 milliseconds time. Also, we have the AFDD, arc fault detection device, which is used for mitigating the arc in the one particular final circuit board. For example, if you're having the DB, final distribution boards, if one of the outgoing feeder, if it is feeding to any critical loads in the home or in even the office environment, like for example, if it's feeding to the IT racks and all actually, okay. If you have this arc fault detection device, it will sense the arc fault very quickly, and it trip the breaker, How it is happening is the arc, for example, if you take the wire piece of, if you take the live wire of phase conductor, okay, if there is a break in the live phase conductor, then small arc will come. The arc is nothing but the high frequency signal actually, okay. This arc fault detection device, which is having electronics inside, which detect that specific frequency of the arc. Normally it's ranging from few kilohertz to megahertz actually. So the particular bandwidth of arc level, if it's happening in the live conductor, it is being sensed by the arc fault detection device, and it's clear the fault actually. Normally what's happening is, if the arc is happening in the any phase conductor like a serial arc, the fault current will not exceed the your MCB rating. For example, if I have the, for example, 10 amps MCB, okay, if there is a serial arc is happening in the phase wire, the fault current will not go more than 10 amps. So the MCB will not trip for any arc actually. When the MCB will get tripped, arc become bigger, and then it leads to insulation failure. When it goes to the short circuit, then only MCB will get tripped actually. But by having this arc fault detection device, when the arc level is at the very initial stage itself, it is detected by the AFDD and it clear the fault actually. Okay. So any serial arc or a parallel arc happening inside the final DB level for any specific circuit, we recommend to put this arc fault detection device. This arc fault detection device also can do the function of MCB. That means it can also give overload and short circuit protection. Also, it can give the earth leakage protection as well. Also, we have the another interesting component. It's called the digital RCCB. See, normally what will happen is, when we have the digital RCCB, then the conventional electromagnetic type RCCB, if the leakage current is between less than 30 percentage, the RCCB will not get trip actually. If the leakage is between 30 to 50 percentage of the leakage current, still it will not get trip actually. But the moment if the leakage current is increasing more than 50 percentage to 100 percentage, then the RCCB will get trip actually. See, the point here to be noted is the conventional electromagnetic type RCCB, which will get trip without giving any warning signal actually. But suppose assume that this it is feeding to any critical loads, okay, you will lose the power supply. That's not the good sign actually. But in our case, by having this digital RCCB, what's happening is if the leakage current is between 30 to 50 percentage, then we will have the local indication on the RCCB itself on the front fascia. Also, we are having the dry type contact. We can signal it to the BMS or SCADA system, or you can use some kind of a lamp or footer in front of the board itself, giving indication that RCC is in the going to get trip after some time actually, so that we can take action well in advance, so that we can do some preventive actions well in advance actually. So this is one of the big advantage of the having digital RCCB. Also, we have the another interesting feature, conditional monitoring in the ACB and the MCCB. Now, what's happening is, uh, normally assume that if you're having a ACB, it's a 10 years old. It's working perfectly generally with most of the manufacturer or the FM team knows very well that the ACB gives a lifetime of 10 years, 20 years also. Okay. But the point to be noted is after 5 years or 10 years, we don't know that whether still the breaker is okay or not. Is it still we can continue with the breaker or not for a longer time? We are not aware. I mean, the FM team they will not be knowing actually. Okay. Suppose if the breaker lifetime is gone, okay, but due to some unforeseen circumstance, if it burned or any fire accident happened, then we will be forced to replace that one. We should have the breaker well in advance, or we should have some spare parts. It should be available in the stock. Otherwise, what will happen is it will lead to the you know prolonged shutdown until you are getting the replacement breaker actually, replacement breaker. To avoid that one, we have the interesting feature in the inside the breaker. We have the kind of what you call the kind of watchdog, which is calculating, taking into account of all these activities actually. That means how many times the breaker operated, how many times the breaker has tripped due to short circuit or overload, how much time it is taking to open and close, what is the ambient temperature around the board. So like that, it is taking into account of all these activities. Then it is giving in the very simple format of the bar graph format, 25, 50, 75, 100 actually. Okay. Suppose if it is showing the bar graph is showing only 50 percentage, it is an indication that we should go for the breaker for the maintenance. If it is reaching the level of 25, then it is giving a signal that we need to replace the breaker actually. Okay. But if you look into the beauty with the E10 system is in all our ACBs, whether a specification is asking for this feature or not, it is coming as a default. This feature is a breaker health monitor in all our E10 ACBs, which is coming. We have the two type of ACBs, the product which is coming from Europe, also the ACB is coming from the Asia region. All the ACBs having this default feature, breaker health monitor. This feature is available with other manufacturers also, but the point to be noted is you need to pay for that actually to have that feature. Also, it has to be indicated in the project specification. But whereas in our Eaton, whether it's indicated in the project specification or not, we are giving this feature as a default in all our ACBs. And it coming to MCCB, it is become an optional feature actually. That's all from my side actually. So now this is the time we can talk about if you have any queries actually. If you have any doubts, we can.
Thank you, Mr. Srinivasan,
Yeah.
for that insightful and very useful session today.
Yeah.
So we'll move on to any question and session, if at all there is.
Yeah.
Now you can switch on your mics. Anyone attendee can switch on your mic and ask directly from the speaker.
Anything in the chat box? Nothing, no? Faisal? Chat box, nothing.
Chat box. Yeah, there is nothing in the chat box.
Okay.
I believe today, as the situation of weather outside, people are.
Yeah.
I hope people are safe.
Yeah.
And we pray for whoever got affected.
Yeah.
For their speedy recovery and all.
Yeah.
Inshallah.
Yeah.
And Mr. Srinivasan will be available in the WhatsApp group if at all there is something in future we can.
Yeah, so maybe I can share this copy of the presentation. Maybe as you said earlier, when you are sending the certificates to them, maybe you can share this presentation also with them so that it will be useful to everybody.
All right, no problem. Okay. Sure, we will.
Thank you, Faisal. Thanks for arranging the session. Yeah.
Thank you. Just before we complete and end the call, I would like to announce the next webinar for all the attendees. There is a webinar coming in the next month by Mr. Samir Hussain from MEP Club. This will be with the topic smoke management system. The date will be April 25th, same 3 o'clock. It will be on Saturday. All right. So by this closing part, I would like to thank everyone, whoever has attended. We will be soon receiving the certification, e-certification for the attendance. All right. Thank you.
Thank you. Thank you.
Thank you, Mr.
Thank you, everyone. Thank you.
Bye.
Thank you.